Hello everyone, I am Clavel and today we'll be diving deep into one of the most essential graph traversal algorithms, breadth first search or BFS for short. So first, let's get to know about breadth first search graph algorithm. So breadth, breadth first search is an algorithm used to traverse or search through the vertices of a graph in a breadth um, breadward of a breadward motion. Unlike the deep first search, which explores as far as possible along one branch before backtracking, BFS, BFS explore level by level. Now, let's take a look at a simple implementation of BFS in Java. So this right here is our code. So first, we have our package. This lines means that um, all our class is put or organized into a single directory. Then this right here is our import. We This line is means that all the classes of Java.util is used, which includes the list, array list, queue, and linked list classes, which is used in our code. And this right here is um, our class. And first, we have the private a private integer num vertices. So this line declares a private integer variable to store the number of vertices in a graph. Then this another private is for declare which is a list of the integers. It represents the adjacency list of the graph, which each list contains the neighbors of a vertex. Then our public BFS graph, which have a parameter of um, int number vertices. So first, this line is this line assigns the provided number of vertices that are to this variable to this variable. Then this right here is initialize or initialization of adjacency list is an array list containing the number of vertices variable. Then we have the for loop. So this for loop initializes each list in the adjacency list to be an empty list representing the neighbors of each vertex. Then we have our method add edge. So this line is used to add an edge between two vertices in a graph. And this line adjacency list that get is um adds the vertex 1 to the list of neighbors which is vertex 2. Since the graph is undirected, the edge is added in both directions. And the same goes for this line. Then the this curly bracket signifies the end of our method. Then another method, BFS. So this line declares a method to perform BFS starting from a given start vertex. So in the next line, we have the Boolean. This line declares a Boolean way of a Boolean array visited to keep track of visited vertices during um during BFS. Then we have the initialization of our queue list to create a queue using linked list to store the vertices during the BFS traversal. Then this line marks the start vertex as visited. Then adds this line adds the start vertex to the queue. The next we have the while loop. So this while loop continues until the queue is empty in our code. So this next line is this removes the and retrieves the front of the queue, representing the current vertex being the being processed. The next is just a simple display of our current value of the vertex. Then we have the inner for loop. Then this for loop s- um this loop over a the neighbors of the current vertex. So next is we have the F statement, um, F conditional statement, which have a condition of um, not not visited neighbors, which means that this check if the neighbor has not been visited. If not, it marks the neighbor as visited and adds it to the queue for further exploration. So that's all for the method BFS. Then this curly bracket is for the for loop. Then this is for the I mean this is for if, then this is for, this is for while, and this is the curly bracket to end our method. The next we have our um main method. So this is our main method syntax. Then we have the scanner initialization to use it in simple input for our graph. The next we have the display. We have this line display these characters to prompt the user to enter the number of vertices in the graph. Then this here is to store and get the value that the user will input. Then we have our BFS graph initialization. I know, not visualization. Initialization. This is a BFS graph with a value of, I know, that's right. It's initialization, and it has a value of num vertices. Yes, that's right. Um, this instance, this instance of the BFS BFS graph with a specified number of vertices. Then this line is just to display this text to prompt the user to enter the number of edges in the graph, then store and get the number that the user will input. And the same for this one, just a simple display to prompt the user to enter the edges of vertex 1 and vertex 2. Then we have the for loop to to repairs the number of vertices representing the edges and adds them to the graph. So this next line So this next line is used to um, store and get the input that the user will input in for the value of vertex 1. Then next is to get and store the value of vertex 2, and it will store in this variable named vertex 2. Then we have a graph method to add the edge of vertex 1 and vertex 2, then curly braces to end our for loop. The next we have the system that out the print to display this string or characters to prompt to um tell the user to um prompt the user to the starting vertex for BFS. The next the next then this next line is store and get the value that the user will input. Then this is for just a simple um display for bit first starting from the vertex that the user inputted. Then we have the method graph that BFS with a parameter of start vertex to display the um, graph value that the user inputted. Then this curly braces means this is for uh, our main method curly braces. Then this is for curly method that signifies the end of our class. So let's try to run it. So this is the output. Enter the number of vertices, let's say for example 5. Then the number of edges in the graph, let's say 4. Then we have to input vertex 1 and vertex 2. So let's say 0 and 1, then 1 and 2, 2 and 3, and 3 and 4. Then the starting vertex for our BFS algorithm. So let's say 1. So this is the output. And that's all for BFS graph algorithm explained by Clavel. Thank you.